This presentation is entitled From Sample to Result, Maintaining Quality Every Step of the Way. And biomedical scientists are involved in testing patient samples from the cradle to the grave. And this often starts with the newborn heel prick test, which is ideally performed when the baby is 5 days old. 4 drops of blood are collected and applied to the blood spot card, and it tests for 9 rare but serious health conditions. It's a really important test that's carried out right at the beginning of life. And biomedical scientists are involved in testing patient samples throughout their lifetime, testing in a variety of laboratory disciplines, including those listed on this slide. Biomedical scientists are also involved in testing post-mortem samples, and some examples of the testing that are performed by BMSs on these post-mortem samples are detailed in this slide. It could be looking at troponin levels in the biochemistry department, or it could be looking for bacterial or viral infections in the microbiology department. Laboratory testing can be divided into 3 main phases: pre-examination, examination and post-examination. Sometimes these are referred to as pre-analytical, analytical and post-analytical, but they're essentially the same thing. In the pre-examination phase, we need to make sure that the sample has been received from the correct patient. We need to check that the information received in the specimen request form matches that which is on the specimen itself. And a number of labs have implemented a minimum acceptance criteria where they stipulate what information must be received on the sample request form and what information must be received on the sample itself in order for the sample to go through for testing. In addition to checking the patient demographics, BMSs are also involved in checking that the sample itself is appropriate for testing. For example, checking if it's hemolyzed, checking if the wrong blood tube has been used to collect the sample, making sure that it's not too old for testing and that has been received within the required temperature requirements. There are a number of quality indicators that we can monitor to track the effectiveness of our pre-examination processes. These include the number of samples not meeting the minimum acceptance criteria, the number of samples collected in inappropriate containers, the number of samples with insufficient volume, the number of samples hemolyzed, or the number of samples clotted, etc., and the list could go on. It's really important to track this information so that it can be fed back to the service users. For example, if a particular department is continually sending their samples in inappropriate containers, it would be important for them to know that and for the lab to flag that up with them. The next phase of testing is the examination phase, and as biomedical scientists we need to be assured that the results we're releasing are accurate. And in the examination phase, there are a number of ways in which we can do that. We need to make sure that our methods are either verified or validated and that they're clinically appropriate. If we're using a kit or a reagent as per the manufacturer's instructions, we need to verify that the kit behaves as it should in our hands. If, however, we're using a kit or a reagent outside of the manufacturer's scope, then we need to validate the method. For example, if a kit is intended to be used with EDTA blood and we wish to use it for CSF specimens, then we need to validate that this kit is appropriate for this sample type. We need to make sure that the test is clinically appropriate and therefore engage with clinicians early on when bringing on a new test or developing a new method. We need to make sure that the test is going to be delivered in a clinically appropriate time frame and that the sample type is also appropriate. We need to make sure that equipment is calibrated and maintained as per the manufacturer's instructions, whether that be daily, weekly, monthly or annually. We must have records to show that this calibration and maintenance has been carried out and passed. We need to acceptance test kits and reagents before we bring them into use with patient testing. Sometimes kits or reagents could be outside storage temperatures whenever they're in transit, so it's important to ensure that kits and reagents haven't spoiled during transit. Internal quality control is also important in this phase of testing. For example, having a positive and negative control for a PCR test. Third-party controls are also an important aspect of the examination stage. These are independent and unbiased controls. They're independent from the manufacturer of the kit, and they're independent from the manufacturer of the equipment. Typically, laboratories would process the third-party control about 20 times and generate data using different operators and different lots of reagents. They'll calculate the mean and the standard deviation and define limits for the control. And this control will then be used on subsequent runs with patient samples. And the lab will track and trend the third-party control data on Stewart or Levy-Jennings control charts, and they'll also apply Westgard rules, and that will determine whether a run can be released or withheld depending on the third-party control results. Internal quality assurance is another aspect of ensuring the quality of results, whereby you repeat test a proportion of samples that were tested in the previous month. The percentage of samples that are retested is really dependent on the volume of samples that are going through a particular lab. Participation in EQA schemes is an effective means of monitoring the quality of results from a particular laboratory. There are a number of different scheme providers, including NEQAS, QCMD, Lab Quality, and Instan, to name but a few. I'm sure there are many more. And they offer qualitative, quantitative, and interpretive schemes for labs to participate in. Typically, they issue samples periodically throughout the year. Labs will test the samples, report them back, and in due course, the provider will issue a report indicating how the lab has performed in comparison to their peers. It's important that these samples are tested by all grades of staff who are involved in testing patient samples, and this includes junior and new members of staff. These samples should not be reserved for testing by senior biomedical scientists within the laboratory. EQA schemes will take a look at the pre-examination, examination and post-examination phases of testing, so give an overall picture of the quality of testing performed by a lab. Occasionally, faults or occurrences happen within a laboratory, and it's important that regardless of what the incident is, that it is documented and investigated appropriately. There should be a thorough root cause analysis, a risk and patient impact assessment should be carried out, and corrective and preventative actions put in place. It's a good idea whenever you're documenting non-conformances that you use a keyword so that you can track and trend the data. For example, if you find that there's an incident that keeps happening, that would indicate that the corrective and preventative action was perhaps not as effective as you thought it might be. This might prompt an audit being undertaken. Audits can be horizontal, examination, or vertical. Horizontal, looking at a particular aspect of a test. Examination, following someone carrying out a particular procedure. And vertical, looking at how a sample was processed right from receipt through to reporting. A risk-based approach can also be used to determine which audit should be conducted. For example, if you have been carrying out a test for say 20 years, you haven't had any non-conformances, there are no issues with the test, you maybe wouldn't want to audit it as frequently as maybe a newly introduced test or a new piece of equipment, etc. So a risk-based approach to audit is also advisable. Within the laboratory, you need to ensure that the laboratory staff have been appropriately trained and are deemed competent for the testing that they're carried out, and there needs to be documented evidence of this available. Staff should not be working unsupervised on patient samples without having been deemed competent. It's important within the laboratory setting that there are standard operating procedures for staff to follow, and that appropriate document control procedures are put in place to ensure that the most up-to-date standing operating procedure, and indeed any laboratory document, is available for staff to access at any time. There are a number of different quality indicators that could be used to monitor the examination phase of testing, and I've indicated 3 on this slide. And these include monitoring the number of incidents where IQC data was found to be outside the defined limits. It could be monitoring the number of unacceptable performances in EQA schemes, or indeed the number of repeat tests that a laboratory had to undertake. The final phase of testing is the post-examination phase. And during this phase, it's important to review and verify the laboratory results, to check for any transcription errors, and to make sure that any calculations performed have been carried out correctly, and that any confirmatory tests have been actually performed. It's also important to ensure that appropriate reporting or interpretive comment has been applied, and that if the result needs to be telephoned out, that it has been telephoned out within the agreed time frame. It's also important that if an incorrect report has been issued, that there are effective means of recalling that incorrect report. It's also important to make sure that results are reported within a clinically relevant time frame, and that all samples are archived and laboratory documentation is archived after testing. This slide gives examples of quality indicators that could be used to monitor the performance of the post-examination phase of testing, and include monitoring the turnaround time. This is whereby the actual turnaround time of testing is compared to that which is reported in the user manual. Another example would be monitoring the percentage of incorrect laboratory reports that are issued. And the third one relates to critical results that are released by the lab. So some results need to be released or relayed to a clinician within 30 minutes of being available. And this indicator would be monitoring, have those critical values been relayed to the clinician within the agreed time frame. There are serious consequences if laboratories don't have adequate control in place, and these can include potential misdiagnoses or incorrect treatment, could be treatment delays, compromised patient safety, time wastage, budget implications, and damage to the laboratory's reputation. As biomedical scientists, we want to ensure that we have appropriate QC steps in place for all phases of testing, pre-examination, examination, and post-examination, so that we're issuing the right result on the right specimen that is accurate, timely, and properly interpreted.